So this session is on Paymail, P2IP, and HD wallets. So Paymail is a set of protocols that allow BSV wallets to receive payments using email addresses as handles, and I think that's actually huge. You know, I don't think we have even dipped our foot in the pond of that really for what that means for users. You know, for many years Bitcoin was this scary thing. You had to have these big lists of numbers. Now it's as simple as sending somebody an email. And so the protocols cover you know, service discovery, capability discovery, key management, address resolution, and verification of both the sender and the receiver. And collectively, these protocols have been named SV Alias. So Paymail is an aspect of that. So the goals of Paymail are just basically to make payments user-friendly. It's a permissionless implementation, so anybody with a domain can set Paymail up on their domain. You can do self-hosting, you can have third parties hosting, and I expect you know, at some point in the near future, when you set up your domain with like a GoDaddy or somebody like that, it'll be a click to install Paymail, and anybody who has email addresses on your domain will automatically have access to a Paymail address. There's an automatic discovery process which is part of those protocols, and we're going to go into that. It uses public key infrastructure, in particular for IPv4 addressing. But future implementations with IPv6 will use more cryptographically generated addressing to validate IP addresses, and we will get into that as part of the presentation. It has great security and it's very extensible, but it's really on you guys to extend it. And this just covers the actual identification of the user and the provision of Bitcoin addresses. And then you build on top of that. So service discovery process is split into two phases. So you have the host discovery, and that's basically the process of reaching out via DNS and finding the domain that your user's email address is connected to, and then capability discovery. And so SV Alias provides for the ability to have lots of capabilities around wallet features and things like that. And not every Paymail or SV Alias setup will have the same features as other SV Alias setups. And so that's what capability discovery is about. So host discovery is basically like a DNS lookup of the root domain that the email address lives at. So you're looking for the responsible host for that given Paymail alias. And if Paymail is self-hosted, they're actually going to find your server. And you know, some people do raise issues that, you know, DNS, it is possible to spoof DNS. So you know, there are aspects of that that you need to be a little bit careful about. I am not fully versed on DNS and how to protect against that. And if you're hosting it with a third-party provider, you simply do that using a SRV record. So I'm sure you've all set up a domain where you have to go in and set, you know, the text and all those little information that you need to allow that provider to route to your domain. But what that does is makes Paymail compatible with the internet infrastructure that we have today. So it basically means that you can use Paymail now with what we have now. It's not something that we need to build new things to be able to use. So it's ready to go. People are setting up Paymail everywhere. I've seen Degan has already released a service that allows you to send emails using Paymail and attach payments to those emails. So that's really interesting. It's great to see people already building on top of this basic discovery service. So what happens is when the Paymail host has been identified, the sending party must learn its supported features. So this is the capability discovery part. And so these are stored in a JSON file which is placed on the host web server in a folder called .wellknown. And that's like something that's done everywhere. The capabilities of a host are not necessarily reflected in an individual account. So you might have a Paymail address that's provided to you by a given domain name host, like ProtonMail or whatever, and they may have a set of features, but you may not subscribe to that full set of features. So one thing is that capability discovery, someone connecting to them will receive the full set of capabilities for all wallets, not necessarily your wallet. So I just wanted to make sure that I said that, because that could cause problems. I'm not really sure how easily that is worked around, but I think the future of this is going to come with cryptographically generated addresses, and this is something that is a big part of IPv6. The reason we can't do it with IPv4 is basically because that IPv4 address space is already completely full. Like, there's no way that you can actually create addresses that have known unique numbers, because there are no numbers left. And so with IPv6, we now have 4 times the amount of address space, and we can use some of that to generate addresses in a way that can be securely verified without needing to use DNS services. So I think the future of SV Alias is definitely IPv6 and CGA. And I don't know how far along they are in implementing that as part of that SV Alias ecosystem, but certainly in the future this is what's going to be used. This is all built on IPv6. This is all proven stuff. CGA has been around for years. It's already been extended to CGA++. And I don't know if you're familiar with CGA, but it's a way of allowing somebody to hit a domain at a known endpoint and to receive a brand new IP address from that domain, which is verified with a signature inside the packet, and then to be able to route their request to that brand new IP address. And that can be an IP address that's never been seen before and can be a single use IP address. So this is how that signature function works. The picture's pretty small, but there's a signature in here. And what it means is we can now issue IP addresses within Bitcoin payment channels between parties with full privacy. So that you can, like I said, you can hit that known endpoint, receive that new IP address. There can be complete privacy between the two parties who have that payment channel set up. And then Paymail would now direct the payment request to that new known IP address. So that doesn't, you can use this without using email addresses as well. Like, you can do this, do a lot of things within SV Alias. Paymail is, I think, the first implementation of a service using SV Alias. So I think Paymail is the big news now, but SV Alias is, I think, a much bigger news, because it's going to allow for all kinds of different ways of people to identify themselves. And this can be used for handles, just about anything. And you can tie your identity to a known wallet endpoint that then can set up secure payment channels with single-use addresses. I wanted to talk a little bit about HD wallets as well. So this is something that I think we don't fully use, and it's something that Handcash have, they're a bit renegade in this. They kind of threw the book out and went, well, we don't need BIP44, which is, I think, what most people are using. BIP44 is rubbish. It's built around the idea of a shitcoin universe. I would love to see nobody in Bitcoin SV using BIP44. It needs to go. But BIP32 is the basis of what builds BIP44. And so that is how we can create hierarchically derivative key structures, and you can do a lot with those. So, you can have your master tree, master key. You can create trees and branches from those trees, and then leaves. And you can serve people those leaf addresses with when they do SV Alias address requests. And so you can always give people fresh addresses. Your tree structure is allowing you to always find deterministically those same addresses Okay, so BIP32, I think, in the near term is the way we're going to build HD key trees. And we can use branch tags to identify activity within a branch. So if you're a corporation, you can have a branch for each department within your corporation. Even under that branch, you can give separate branches to the individual people who are working within that part of your corporation. Those individual people have their own branches that generate their own sets of addresses, and you can go as deep as you like with these trees. So you can build things that are very complicated, but still very simple to see how it works. It just becomes like a big file structure where every branch is a key that's been used to receive or a Bitcoin transaction. And so yeah, your app can build anything underneath that it likes. And apps just simply scan through the branch, find all the addresses where they should have money, and then you can take that and put that in a Bloom filter and get all of the information back for any particular branch of your tree. And this is just a very simple example. So I could have my brendan@moneybutton.com master key, but under that I might have a money button branch, a tokenized branch, and a Twetch branch. And so the money button branch is just general stuff that I'm using money button for. I might have income coming in from some content that I've put up that people are paying to my money button ID, but I might then have a tokenized branch. So say someone builds a tokenized compatible web page which uses the money button. Well, that would go underneath my money button master key, and I would have a tokenized branch, and within that tokenized branch I might have a set of addresses for vouchers, for shares, and then for RPuzzle coins. And I'll get into RPuzzle coins tomorrow and about how they are used with tokenized, because what can actually happen is those vouchers and shares, they don't actually need to be tied to UTXOs. So you might have assets that exist on public keys to which no coins are attached, and RPuzzles are the key to being able to move those assets. So we're going to get into that tomorrow. I think RPuzzles are really an amazing new technology, and they really changed the game for Bitcoin SV. They're going to allow us to do a ton of really amazing stuff. So yeah, I mean, you can apply different rules to each folder. So you can say that where my money button income comes in, that my money button won't spend from that folder until I've moved it out and into another, like into the spending folder. You can bring money button income in from a particular web page into its own branch and treat that differently to other parts of your tree. But the key thing is that all of your Bitcoin is held in a single structure that you can treat almost like a file system. And like it says, these structures can be as deep or as wide as you need. And one thing I like is that, you know, you can create a system where the first transaction in a branch can claim it for an app. So say I have a master key and then I open a Twetch account, my wallet just goes through and looks for the first available branch and sends a market transaction that says this branch is now for all of my Twetch information. And then later on, if I restore that wallet onto a new computer, that computer just goes through and scans it and says, oh, well, this is the Twetch branch, here's all my Twetch transactions, and brings them back in. And so there's a means there for us to create an ecosystem where apps kind of work together to not kind of tread on themselves, because you can get into a situation, and this is a problem with the money button today. They don't really have any means to distinguish what you're doing with the money button. So I have a website where I sell a product. When money comes in for that product, I would love for the ability to keep that separate, but at the moment I can't. And so what happens is money comes in and then I send a Twetch or something, and it's taking the money that I've earned from that and it's spending it on stupid shit. But I need to be able to report that to the tax office. And they're going to want to see, well, what have you done with that? And oh, I used it to send some posts on social media. Sorry about that. So this is one of the things I think that we need to start getting really good at. It's something that we don't do today. And I think it bears thinking about very carefully when you are building your app is how are you going to structure your HD keys and what are you going to allow people to do with them. The outcome of this, or the main goal, is to keep it simple. Make Bitcoin easy for the user to understand. And so wallets need to be able to enable users to sort income, report taxable items. We need to have accounting systems that can look at these trees and pull information out of them and use those for reporting and things like that, because yeah, at the moment, that's something that we don't have. Wallets have to provide flexible and simple ways to receive, handle, and spend money without compromising basically your tax liabilities, and because that's what's happening right now. And HD keys is a really good way of doing this. So it bears thinking about for everyone here to really learn how this works, learn how to use it. It's not scary, it's not difficult, it's just something that you need to do. So there are other ways to hierarchically determine keys. And hierarchically deterministic basically means that there's a tree and a means to find your way to a branch on that tree. You don't necessarily need to use BIP32, but it's there and it's simple and it's available and it's well known and everybody can use it. But I've seen other schemes that are based on like a Merkle tree where the deterministic addressing comes from the previous transaction ID that a coin was used for. You can follow a particular UTXO as it transitions through through a set of transactions, or the MetaNet is actually, you can do a signature-based tree. I mean, you can use BIP32 addressing trees in the MetaNet, but you don't need to. You can do anything you like, but as long as you have a means to always find your way back to where you were. And I think that's the key thing to understand. And I think probably for most people, you're just going to want to stick to BIP32 until the researchers and that come out with these new schemas. But I do know that longer term, we're going to get some new and different technologies to build these trees. And it behooves you to be waiting for those and to be ready to use them and to understand what HD means for you and as a developer and for your users.